Welcome to Ask and Learn.
Let's find the absolute minimum and maximum values of the function f of x equal x plus 1 over x on the closed interval 0.24. First thing we gotta notice here is that this function is continuous on the interval 0.24 because the only value of x for which we will have discontinuity of this function is x equals 0, which is not included in this interval. So f is continuous, the interval is a closed interval, so we know f attains its extreme values on that interval, and moreover we know that those extreme values are attained either at the endpoints of the interval or at critical numbers of the function. So we gotta find the critical numbers of f, and we start by calculating the first derivative of f, which is equal to 1 minus 1 over x squared. And we can see that this derivative is defined at every point or value x on the closed interval 0.24. And for that reason, the only critical numbers of this function f are those values of x for which the first derivative is equal to 0. Then we gotta start by solving this equation, f derivative equal to 0, and that's equivalent to the equation 1 minus 1 over x squared equals 0, because the first derivative of f is given by this expression. And this is equivalent also to 1 over x squared equals 1, which also equivalent to x squared equals 1. And from this, we know that x can be equal to 1 or negative 1. But x equal to negative 1 is not in the closed interval from 0.2 to 4. Then the only critical number of f in the interval 0.24 is x equal 1. So we got to evaluate the function at this critical point x equal 1 and at the endpoints of the interval 0.2 and 4. And among those three values are the extreme values of the function. So let's start by evaluating f at 0.2. That is 0.2 plus 1 over 0.2, which is equal to 0.2 plus 0.2 is 2 over 10, so this will be 10 over 2 is the reciprocal of that number, and that's 5, so we get 5.2. Now f at 4, which is the right endpoint of the interval, is equal to 4 plus 1 over 4, which is 4 plus 0.25, and so we get 4.25. And finally, f at the critical number 1 is 1 plus 1 over 1, which is 2. And so we can see here that the maximum value of the function over the interval 0.24 will be f at 0.2, which is 5.2, and the minimum value of the function over that interval is 2, attained at x equal 1 at a critical point. So we can now write the answer to the problem. The absolute maximum value of f in the interval 0.24 is 5.2, and that value occurs at the left end point of the interval x equals 0.2. And on the other hand, we have that the absolute minimum value of f in the interval 0.24 is 2, and that value occurs or happens at the critical number x equal 1. So that's the answer to the problem. And then we make a summary now. We first notice that this function attains its extreme value over the given interval because the function is continuous over the interval and the interval is a closed interval. We know moreover that the extreme values, that is the absolute minimum and absolute maximum values of the function over the closed interval, are occurring either at the endpoints of the interval or at critical points or critical numbers of the function. So we got to find the critical numbers of the function. For that, we calculate the derivative of f and resolve or solve the equation first derivative of f equals 0, and we got in this case two solutions, 1 and -1, but we got to stick with solution that is in the interval 0.24. In this case is x equal 1, and now we evaluate the function at this critical point x equal 1 and at the endpoints of the given interval, and from these three values we found that the absolute maximum value is 0.5, attained at the left endpoint of the interval 0.2, and the absolute minimum value of the function over the interval 0.24 is 2 at or attained at x equal 1, which is the only critical number of f in the interval. And remember, we know that this value x equal 1 is the only critical number of f in the interval 0.24 because the other possibility, which is -1, is not inside or within the interval 0.24. So this is the only critical point number of f and is in fact the point or value where the function attains its minimum or absolute minimum over the interval.